Welcome back to my channel, guys. This is the next video. So we are going to talk about half adder. So half adder is basically a combinational circuit which takes two binary inputs, and gives us two outputs, a sum and a carry. So a half adder has the truth table like this. So we take two inputs, let's say A and B, and we get two outputs, sum, which is denoted by S, and carry, which is denoted by C. So we take two inputs, 0 0, 0 1, 1 0, and 1 1, and we write accordingly how we add, just like we have learned previously in our videos how to add. When we add 0 0, we get 0, and carry will also be 0. When we add 0 and 1, we get sum as 1 and the carry remains 0. When we add 1 0, we get the sum as 1 and the carry also remains 0. And when we add 1 and 1, we get the sum as 0 and the carry as 1. So this is the truth table of half adder. Based on this truth table, we are going to make the expression. So if you ignore the C part and just focus on the sum part, you can see that this acts as a XOR gate. A XOR B gives the S output. So we are going to write the expression of sum as sum, or S, is equals to A B bar plus A bar B, which in short we can write as A XOR B. So this is the expression for sum in half adder. Next, if you ignore the sum part and focus on the carry part, you can see that it acts as an AND gate. So A and B gives 0, 0 and 1 gives 0, 1 and 0 gives 0, and 1 and 1 gives 1. So the expression for C or carry would be like this: A and B. So these are the two expressions for the half adder, the sum and the carry. Now, based on these expressions, we are going to make the circuit diagram for half adder. So now we are going to discuss about the circuit diagram for half adder. So the expressions that we got were S equals to A XOR B and C equals to A and B. So based on these two expressions, we are going to draw the expression or circuit diagram of the half adder. So the circuit diagram of half adder would be like, we will take two inputs A and B, and we are going to pass it through a XOR gate. The XOR gate looks like this. We discussed it previously in our videos. It looks like this, and this will give us the sum, which is A XOR B. The next part is the carry part, which is A and B. So once again, we are going to take the input, one input from A, the other input is from B, and we are going to connect it in a AND gate, and the output would be the carry or the C, which is A and B, like this. So this right here is the circuit diagram for half adder. We are going to discuss about full adder. So what exactly is a full adder? Unlike a half adder, full adder takes 3-bit input and gives a 2 output, which is sum, the S, and the carry, the C. So first we are going to write the truth table for the full adder. Let's take A, B, and Z as the 3 inputs, and the outputs are obviously sum and carry. So now we are going to draw the truth table. And we are going to write all the inputs first. And the outputs will be based on these 3 inputs. So first is 0 0 0. So obviously sum and carry both will be 0. Next, since A is 0, B is 0, and Z is 1, we are going to get sum as 1 and carry as 0. Next, A is 0, B is 1, and Z is 0. So we are going to get 1 again, and carry will be 0. Now there's A is 0, but B and Z both are 1. So what we are going to get is, we are going to get sum as 0 and we are going to get the carry as 1. Next, A is 1 and B and Z are 0. So it will be 1 and 0 carry. Then we have A as 1 and Z as 1 but B is 0. So we are going to get 0 and 1 over here. Next, once again, A is 1, B is 1 and Z is 0. So we are going to get the same result. And lastly, when all three are 1, we will get both sum and carry as 1. So once again, if you look at the truth table and if you ignore the C part, you would see that the S or the sum part is basically A, XOR B, XOR Z. So just like that, we are going to write the expression for sum, which is S equals to A, XOR B, XOR Z. And the expression for C, if you ignore the S part, you are going to see that it's basically AB plus BZ plus AZ. We can also get this by K mapping S and C, but we are not going to discuss it here. Next, we are going to talk about the circuit diagram for the full adder. So next, we are going to discuss the circuit diagram for full adder. So first, let's write the expressions. The expression for sum was A XOR B XOR Z, and the expression for C was AB plus BZ plus AZ. So these are the two expressions. Based on these two expressions, we are going to draw the circuit diagram for full adder. So for drawing this, first we are going to pass the A, B and Z three inputs through a XOR gate. So it's going to look like this. First there is A, then there is B and then Z. We're going to pass it through a XOR gate and the output will be A XOR B XOR Z, which is S. So this is how we get the sum. Next we are going to get the C. For that we are going to pass A and B through an AND gate, A and B through an AND gate. Then we are going to pass B and Z through another AND gate. Here's Z and here we can take B. Lastly, we are going to pass A and Z. So we are going to take A and Z from this side and pass it through an AND gate. Now we are going to take all three of the outputs from the AND gate and pass it through a single OR gate. This will be our C, which is AB plus BZ plus AZ. So this is the circuit diagram for full adder. With this, we are completing the full adder and half adder video. Thank you for watching my video and I hope you like the video. If you do like it, please subscribe, share and like the video and press the bell icon. Thank you for watching.